Let's take a look at exercise 8.4.7, where we want to multiply two radicals that involve integer factors as well as variables that are exponentials. All right, so the first thing we want to do is we want to make use of the product rule of radicals. And we are assuming all variables are non-negative values. So if I have the product of two radicals that have the same index, so the only thing that needs to be the same here is the index of the radical. Here the index is an unwritten 2, since these are both square roots. So I'm going to multiply 28 by 18, and x cubed times x times y cubed times y squared. So this is equal to the square root of 504 times x to the fourth times y to the fifth. All right, so we are looking for the largest perfect square factor of this radicand, 504 x to the fourth y to the fifth. And we have to think about, and so we're going to multiply this by, we're going to break this radical into the product of two radicals. And so we think about the perfect squares, and we get that list by beginning with 2 and squaring it. That result, 4, is the first number on my list. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. So whatever your index is for your radical, you want the perfect. So if the index is n, you want the perfect nth powers. In this case, n is an unwritten 2. So I start with 2 and raise it to the nth power, which in this case, n is 2. And we could keep going and going with this. It actually goes on for indefinite. So we could continue the list. We're going to write it as 504 as 36 times 14. X to the fourth is a perfect square, so that goes in the first radical. Y to the fifth is not, but we can write that as y to the fourth times y. So notice when I'm working with a square root, the index is an unwritten 2. If that index value divides evenly into these powers, then these powers are a perfect nth power. So in this case, a perfect square. So this is 6x squared y squared. And notice the index is 2. To find the square root of x to the fourth, I simply divide this power by the index. And since the index is an unwritten 2, the power, when I apply the square root, is 4 divided by 2, which is 2. So this is multiplied by the square root of 14y. So that's my simplest form of the expression that I begin with. So notice in this case, first I had to multiply, then I simplified.